Hello, and this is my implementation of strategy pattern-based architecture. I have each of the other implementations finished for the different variants of Civ. The only one that I have left is Beta Civ, specifically for the aging algorithm used. So currently, we have the Alpha Civ aging algorithm in this game implementation file, where simply at the end of every person's turn, the age will decrease by 100 because it starts at 4000 BC and it will decrease up until 3000 BC, where red player wins. So we will be using the strategy pattern-based architecture to rebase this code and make it more modular for whenever we want to implement beta sim. So the first thing that I'm going to do is I am going to make a framework, and we will name this aging algorithm. And we'll add this to the Git. And I think the only thing that we really want this algorithm to do is to calculate what the next year is going to be based on the current year. So I'll have it return an int, or I'll make it public. We're going to have this return an int based on what is passed to this object. So I'll do public int next age. How about that? And then I'll call it int current age. And this is just an interface, so we don't need any implementation in here. So that looks good there. And then what we'll do here is we will make a class for the Alpha Civ aging algorithm, and we will call it exactly that. Algorithm, my bad. The Civ aging algorithm, there we go. So, and we want this to implement the aging algorithm interface that we just made. And for this we have, it's a public int that returns an int. And we will, there we go. So just copy and paste that here. And the current algorithm that we have is that it will take the current age and it will subtract 100 and then pass that as the next age. So we'll just do return current age, not plus, but minus 100. So that looks good there. Now we want to implement this in our game implementation file. So we want this to be a new variable. So I'll call it private aging algorithm. And we'll name that variable aging algorithm 2. And then for our two constructors, we'll automatically initialize it. So I'll say this.aging algorithm equals new Alpha Civ aging algorithm. And as a test for this, for our actual constructor, I will do the same thing. So whenever this gets changed, what we're going to do is we're also going to pass an aging algorithm variable called aging algorithm, and we will set it to that. And then what we will do is down here, where it was automatically calculating the new age, we will just have age equals aging algorithm dot next age, and then we'll pass age there. So what I decided to change here is a lot of these test cases run off of the default game implementation constructor. However, I want to make sure that this new AlphaSieve aging algorithm object gets passed to the constructor, as you can see here in game implementation. That way that the aging algorithm is properly set to the AlphaSieve aging algorithm. That way, whenever we want to make new aging algorithms, like say for BetaSieve, we could just automatically pass that new object to that. And that is the entire concept behind strategy-based pattern architecture. So this should run because there are only 2 players in the game, and after the turn ends, the new age will be the initial age minus 100. So let's run this test. And it passes, which is great. And then, just to make sure that this didn't mess up any of my other test cases, I'll run the entire file, and all 28 tests pass. So, that is my demonstration of strategy-based pattern architecture to rebase my code. Thank you for watching.